Now we do the high frequency analysis. We use the same technique, okay, drawing the AC equivalent circuit using hybrid pi model. Okay, for circuit number 1, we have voltage divider bias for the BJT and our resistor RE without any capacitors bypassing it. Meanwhile, for circuit number 2, okay, we have voltage divider bias to the BJT with resistor RE bypassing with capacitor CE. So, during our class previously, what affect the high frequency analysis for the circuit is, what affect it is, firstly is the internal wiring. The second one is the internal capacitance of BJT. Okay, so I label it here. For internal wiring, we will focus on wiring input, okay, CWI, C wiring input, and also C wiring output. Okay, for internal capacitance of BJT, we consider the capacitance between the BJT junction. Okay, so here we have CBE. Therefore, here we can have 3 capacitance between CB terminals, between BE terminals, and also between CE terminals. So here we have CBC, here we have CBE, and another one is CCE. Okay, so these 3 values. I label it here, CBC, CBE, or CCE. Okay, so we have 5 capacitors that we need to consider in our calculations. Alright, so now let's draw the AC equivalent circuit. Okay, the C1, C2, and also on the right circuit we have CE. Okay, all of the circuit is closed. Okay, closed or short circuit. It is not short broken, but it is short means the current is flowing through it. Okay, so now we need to draw the AC equivalent circuit for high frequency analysis. Okay, so same like in previous step, firstly is we need to know where is the input and also where is the output. So here for the circuit, the input is at the base, the output is at the collector. Okay, and then there is another terminal for the BJT, the emitter. Okay, so we draw the R pi, current. Okay, this is NPN, so P is, base is positive, P type, emitter is N type, so V pi positive is at the base, emitter is negative, the arrow for current is from C to E. Okay, and then we just draw all the components that available in the circuit. So here at the input we have R1 and R2. Okay, what else we have? C1 is closed circuit, VS, RS. Okay, then at the output, at the collector, we have RC, and then C2 is closed circuit, and then we have RL. Here we have V out. Okay, and then another one is RE. This is GM V pi. Okay, and then we need to add these 5 capacitors into our AC equivalent circuit. We have C wiring input, C wiring output. So we draw C wiring input over there, C wiring output at the output, and the internal capacitance between BJT junctions. So we draw the 3 capacitors. This is C, B, E. Here is C, C, E. And there is a capacitor between CBC junction. Alright, so here we need to apply. Okay, we need to apply Miller theorem to replace CBC. Okay, and then CBC will be C Miller input and also C Miller output. Okay, so the replacement, okay, is made by replacing the capacitor with another 2 capacitors connecting at each of the node. Okay, means you need to connect the capacitors at the base and also at the collector. Okay, so just draw at any point over here. So this is C Miller input, and another one is at the collector node. Okay, so this is C Miller output. Alright, now we can remove CBC over here. Okay, so I just erase it using eraser over here. Okay, and then we can simplify again the circuit. Okay, we can simplify all of the capacitors, right? Because this is parallel, so the capacitor we can replace with 1 capacitors, and also the resistor we also can simplify it. So I just draw the capacitor at the output RC parallel with RL, and the capacitor is V plus CCE, similar output, and also C wiring output. Okay, at the input part we have 1, 2, 3 capacitors, C wiring input plus C Miller input plus C BE, and also the resistors R1 parallel with R2. Okay, so that's it for the equivalent circuit. Equivalent circuit for circuit 1. Okay, so we need to continue for circuit 2. Alright, so for this one, you see the difference is at the emitter part. Okay, so here what happened during high frequency analysis? The capacitor is shorted, right? Okay, so what happened to RE is that the current is more likely to flow to the closed circuit wiring over here. Okay, therefore, from the emitter part here, the current will flow to the ground. Okay, so what happened to the AC equivalent circuit? We can remove the RE. We just draw. This is for circuit 1. So for circuit 2, the emitter is connected to the ground. RC parallel with RL, GMV pi. Don't forget the label. Okay, so this is for circuit 2. Okay, so that's it.